this set of notes, we're looking at nth roots, radicals, and rational exponents. Make sure to check on your paper for the announcements, and so that you know what due dates you have coming up. So when we look at some of these roots, we need some vocabulary, which I have here. Okay, this is called the base. Okay, a base is usually a number, can be a letter, and it's raised to some kind of power, which we call the exponent. Now, when we go to solve an equation, I could do what's called the nth root. And the nth root enables you to find what this constant would be. So the inverse operation of an inverse is to take a root with the index that matches your exponent. So in this case, this one asks me, what are all the real fourth roots of 16? So the way that I'm finding that is I am actually doing a factor tree for 16. And so I found that prime factorization. So the fourth root of 16 is 2 times 2 times 2 times 2. And when you take a set of 4 of those out, you get the number 2. Now it's really important, if you're finding a fourth root or a square root, so some kind of even numbered root, you need to include the plus or minus symbol. If you're taking an odd root, then you can just keep whatever sign you have there. So let's try it again here with 81. So if I do the prime factorization of 81, okay, I break it apart and I get 4 3s. So the fourth root of 81 is the same as the fourth root of 3 times 3 times 3 times 3, which means that that set of 4 3s comes out, and because that's an even index, I put a plus or minus symbol on there. Let's talk about 64. Now 64 I know is 8 and 8. And I'm finding the prime factorization on this. I could have broken it up in a different way than I am doing here. But if I didn't know my number sense so good, I would keep doing this factorization like you see here. Okay, so it's a cube root, which means that my index is 3. And when I look at the leaves on my factor tree, I had 6 2s, so I'm writing 2 6 times. So my index of 3 means that I'm taking out sets of 3 of these expressions. So I'm taking out a pair of 2s, which would mean 2. Now this index is odd, it's a cube root, so I don't need to put the plus or minus symbol, I could just call it good from there. Alright, one more time with 27. I'm ignoring the minus sign that's on there. It's a cube root, which means that whatever comes out of it's going to be a negative number. So 27 is 3 times 9, and 9 is 3 times 3, so I have the cube root of negative 3 times negative 3 times negative 3. And there's 3 sets of negative 3 there, so it keeps that negative on here. Now, we use these roots to help us to deal with rational expressions. So we have this rule here. It says if you have an exponent that's a fraction, sorry, just making that a little darker, then the bottom of the fraction, the denominator, is the index of the radical, and the numerator of the fraction, the top, is the exponent to the variable. Now sometimes that exponent can also be outside of like parentheses. So the instructions on this say to write the following in radical form. Alright, so 7 is the base, so it's going to come inside the radical. The 2 is in the numerator, so it gets to be the exponent. And then the 3 is in the denominator, so it gets to be the index. Let's try it again. So this time, I have a b for my base. The numerator is a 1, so I could put a 1 here, but we tend to not write a 1 for exponents. And then I put a 5 where the index is. One more time, I have a base of p. The numerator of the fraction is 7, so that's my exponent. And the denominator is 4, so that's my index. So that's how you write a rational expression as a radical. Sorry, yeah. Now, when I go to simplify the radicals, okay, which I'm doing just like I did up there, I need to think about absolute values, okay? The absolute values are going to get used when my index, which is the number that's like on the rain gutter of their house is what I call it, is even, and the exponent on the inside is odd. Okay, so in this case, the square root of 81, I know 81 is 9 times 9. Okay, so I'm going to pull a 9 out. And the square root of x to the 4, right, I'm assuming there's a 2 here, means that I could take this x to the 4th and take out a pair of x's, which is just x squared. Now everything here is even, so I'm just going to go ahead and call it good with that. All right, so looking here, okay, what I'm doing really is I'm doing division. Another way that you could visualize this is you could write it in fraction form. So this is a to the 12 thirds and b to the 15 thirds. And you could just reduce the fractions. That is often easier. So that's a to the 4th, b to the 5th. Or just recognize that you would divide the index out of the exponent. Now sometimes it won't evenly divide, and that could be really annoying. Now this was an odd index, so we don't really have to worry about the absolute value bars. But on this last one, we have an even index. And so when I go to pull stuff out, right, this x would be x to the 3rd, and the y would be y to the 4th. The x to the 3rd gives absolute value bars to keep it as a positive number. Because if x to the 3rd could have been a negative, like negative x to the 3rd, like that, it would still simplify in here, but it doesn't quite work out because you can't take an even exponent of a negative number. All right, so let's solve some equations. So the way that you solve with these things is first you need to isolate whatever exponent you have. So I need to get the x cubed by itself. In order to do that, I'm dividing by 4. And then what I need to do is I need to take the cube root. So the opposite of a power is to take the reciprocal. All right, so I'm going to raise both of these to the 1/3. Because the power property says if you multiply together the exponents when you have two bases. So this one will just turn into an x, which is nice. Now 81 to the 1/3 is the same thing as the cube root of 81. So I'm breaking apart 81 to figure out the cube root. All right, there's a whole bunch of 3's that are vibing here. So I have the cube root of 3 times 3 times 3 times 3. So I take out one set of the 3's. And I don't need the plus or minus or absolute values because I have an odd index. Trying again here. So I need to isolate the x to the 4th. Oops. So I'm dividing by 2. So I get x to the 4th equals some number I don't know. Let's go ahead and use a calculator on that. 1250, I probably should have known that one. Now finding the 4th root of 1250 is kind of, right? I have to actually break it apart. So in my factor tree, right, I know that it ends in 0, so that means it's divisible by 10. 125 ends in 5, so I know it's divisible by 5. And 10 is 5 times 2. So I'm going to go ahead and raise each of these sides to the reciprocal of 4, which is 1/4. So I get x equals, this is going to be a even index because of the 4, so I'm going to put the plus or minus. And I need 4 of a kind with these leaves to take something out. So because I have 4 5s here, the 5 can come out. And inside that 4th root, that 2 can't come out because of the, because there's only one of them. There's not 4. So this would be the final answer here. All right, 2 more of these. So in this case, the exponent's already isolated. There's nothing multiplied out here, or divided, or added, or subtracted. It's just something cubed. Okay, so I'm going to raise it to the reciprocal function, which is to the 1/3 there. So when I do that, I get x minus 2 equals the cube root of 10. You can leave it as 10 to the 1/3. Just check your instructions. Usually the instructions will tell you to answer as a radical or as a rational exponent. Alright, now x still isn't alone here, so I'm going to add 2 to each side. And usually we like the radical to be second, so I'm going to put the 2 right here. It's also worth mentioning, this is an odd index, so I'm not using plus or minus. Okay, one more round. This one's a 4th. So I'm going to go to both sides, raise it to that reciprocal power, which is to the 1/4. So I got to break apart that 256 real quick. It's even, so that means it's divisible by 2. 128, I see a 12 and an 8 in there, which are both divisible by 4. So to save myself a little work, I do that. 32 is also divisible by 4. Alright. Jeez. So when I do this, right, I get x minus 4 equals, now this is a 4th root, that index is even, so I'm going to put a plus or minus on there. And it looks like I have 1, 2, 3, 4, 5, 6, 7, 8 2s kind of chilling in here. So I'm going to write down the number 2 8 times. And I'm looking for sets of 4 because my index is 4. So I have 2 sets of 4. So those 2 sets of 2 is 4. So I need to add 4 in order to get the x by itself, to isolate it. Now the thing is these are numbers that are like terms, so I can actually solve that. So I'm splitting it into 2 equations. One where it says x equals 4 plus 4, and one where it says x equals 4 minus 4. So my 2 possible answers are 8 and 0. Which feels a bit excessive, but there we are. So there we have it. We're just going to keep practicing that in class. Please make sure that you pause the video somewhere in here. Make sure that you get all the notes written down.